So what we're doing here for the trig functions for the rest of basically the course, we're going to be dealing with the xy plane, and so knowing the quadrants, right? So this is quadrant 1, and then those measures of angles. In other words, if I draw an angle in here, let me do the same color as the thing. So if I draw, we always start on the initial side, which is the x-axis, the positive x-axis. Okay. For quadrant 1, the measure is going to be 0 to 90 degrees. Also, in radians, it would be 0 to pi over 2. This one over here would be pi over 2 theta to pi. This one down here would be from pi to 3 pi over 2. And then lastly, the fourth quadrant, I don't have a purple marker, so I'll just use red again. It's going to be 3 pi over 2 to 2 pi. And then you've already written down all the angles. So I don't think you need to memorize this, but it is helpful to kind of know, right? Remember that our positive angles are always going to rotate around this way, okay? So those are important things. So at some point in time, they're going to say, find sine of 3 pi over 2, or, 195 degrees. It's important to know what quadrant that's in, because there's some rules that take place in the different quadrants, okay? Can I move on to the next slide? No? Okay. I'll wait a second. Okay, what about now? Yeah? Okay. So here is the basic rundown. What we're going to do is we are going to use angles in the xy plane. So I'll have an angle like this. And so one way to get there is this way. Another way to get there is this way. So if I were to call this alpha and call this beta, we would say that alpha and beta are coterminal, right? And so what does that mean that they are coterminal? Well, there's a couple of things. Remember that this is the initial side, and this is the terminal side. So while one angle would be a negative angle and the other one would be a positive angle, and we can make multiple revolutions and stuff, but basically the reason they're called coterminal is because they exist in a space, right? And if I think about that, wherever that angle lands, if I wanted to, at some point in time, this corner is an x comma y value in the two-dimensional Cartesian plane. So what that means is I could draw a straight line down here, and this forms a 90-degree angle, and then this is like the hypotenuse of the triangle. Now, the interesting thing about this is that the distance from here to here is equal to my y value, right? The distance from here to here is equal to my x value. In other words, my x value for this one is -4. My y value, well, we'll just put the dot up here so it's easier, is 3. So this is like -4, 3. Well, technically, that's like, isn't that the adjacent side, the opposite side? And so over here, this crazy looking thing that I'm just introducing to you today is what we call the unit circle. Okay? And so the unit circle, these are the xy opposite adjacent sides. If I were to drop a straight line down here, my x value would be √3/2, and my y value would be 1/2.